This is the video introduction to Lesson 21, How to Measure Current with a Digital Multimeter, in the Mr. Circuit Basic Electronics Lab 2. Before I explain how to measure current, I would like to talk about unit conversion. That is, converting from amps to milliamps to microamps and vice versa. This is covered in this Lesson 21 on pages 21A1 and 21B1 in your lab manual. First of all, in electronics, we're generally working with small amounts of current. An amp is equal to 1,000 milliamps. An amp is also equal to 1,000,000 microamps. To convert amps to milliamps, you multiply the amps by 1,000. To convert amps to microamps, you multiply the amps by 1,000,000. Let's practice. 2 amps equals how many milliamps? Answer, 2,000 milliamps, because you multiply the 2 amps by 1,000. 3 amps equals how many milliamps? Answer, 3,000 milliamps. 2 amps equals how many microamps? Answer, 2,000,000 microamps. You multiply the amps by 1,000,000. 3 amps equals how many microamps? Answer, 3,000,000 microamps. Let's try some more. First, 2 thousandths of an amp equals how many milliamps? Answer, 2 milliamps, because 2 thousandths of an amp and 2 milliamps are the same thing. How do we get the answer? We move the decimal to the right 3 places, which is the same as multiplying by 1,000. Second, 2 thousandths of an amp is equal to how many microamps? 2,000 microamps. How do we get the answer? We move the decimal to the right 6 places for multiplication by 1,000,000. So, to convert from amps to milliamps, you move the decimal 3 places to the right. To convert from amps to microamps, you move the decimal 6 places to the right. And it also works in reverse. If we convert from milliamps to amps, we just move the decimal 3 places to the left, which is the same as dividing by 1,000. Thus, 100 milliamps becomes 0.1 amps. If we convert microamps to amps, we move the decimal 6 places to the left. So 1,250 microamps becomes 0.00125 amps. You see that if you divide 1,250 by 1,000,000, you get 0.00125. If you do this a few times, it becomes easier. After you watch this video introduction, you can practice by filling in the blanks on pages 21A1 and 21B1 in your lab manual. Now that you're a little more familiar with the terms amps, milliamps, and microamps, let's talk about how to measure current with a digital multimeter. On this digital multimeter, there are 5 different selector positions for measuring current. The selections are 200 microamps, 2,000 microamps, 20 milliamps, and 200 milliamps, and 5 ADC. ADC stands for amps direct current. Note that to measure 5 amps, you have to move the red plug to the 5 ADC jack. At this point, I need to emphasize that when we measure current, we must take care not to exceed the limits of the meter. We need to understand the circuit we are measuring as to the possible amount of current that can be flowing. With LED circuits, we are usually working with about 20 milliamps. If you are unsure of the amount of current in a particular circuit, Start with the highest range, which is 5 amps DC on this meter. Just a note, we usually won't be measuring that high of a current, so we will seldom use this function. One more piece of instruction. We measure current by inserting the meter in series with the circuit under test. Here is a simple circuit with a battery, an LED, and a resistor, with a meter shown in series with the circuit. How do we measure the current flowing in this circuit? Be careful. To put the meter in series with the circuit means we had to break the circuit and put the meter in to complete the circuit. Notice the schematic diagram. The circle with the M in the middle represents the digital multimeter. Notice the meter is actually in the circuit. That is to say that all the current flowing in the circuit has to pass through the meter. We show the red lead of the meter connected to the resistor and the black lead connected to the anode of the LED. Which direction does the current flow? It flows from the negative of the battery into the cathode of the LED. Then it flows out of the anode of the LED into the meter. Then the current flows out of the meter into the resistor, and from the resistor into the positive of the battery to complete the circuit. Before we actually connect the battery to the battery snap, we need to set the selector knob. Where should the selector knob be set for this measurement? Well, we expect the current in this circuit to be less than 20 milliamps, so we set the selector on the 20 milliamp position. Actually, I would start by putting the selector on the 200 milliamp position, connect the battery, and see what it measures. If it measures under 20 milliamps in the 200 M position, then I would move the selector knob to the 20 M position and get a more accurate measurement. Well, that's it. In this video introduction, we explained about unit conversion, amps, milliamps, and microamps, and how to make current measurements with a digital multimeter. In the next lesson, we will actually build a circuit and connect the meter and measure the current. To complete this lesson, go to pages 21A1, 21B1, 21A2, and 21B2, and fill in all the blanks and questions. Remember, there's a 2-page answer sheet in the back of your lab manual so you can check your answers. Good luck, and I hope you're enjoying learning electronics. Only 9 more lessons in this lab until you qualify for the Certificate of Training for the Mr. Circuit Basic Electronics Lab number 2.